Hello dear student of class 10th. Now we are going to discuss our first chapter, part 5. Okay. Further, I would like to discuss that in part 4 what we have studied at the part 4 what we have studied. First, we have studied that moment means torque. Torque is equal to force into perpendicular distance of the force from the point of axis of rotation. It means that we have studied the formula of moment. And what is the moment? Basically, if any object is hinged, means fixed at a particular point, and we are applying some force on the another point, and then the moment will be force into perpendicular distance. Moment will be force into perpendicular distance. That is also denoted by tau torque. Okay. In the second part, we have discussed that moment of a couple means if a rod is applied by a force, two force that is equal and opposite in direction. That is equal and opposite in direction. It means that one force F is applied in this direction and another force of same magnitude applied in this direction, in which the rod AB will start moving. AB will start moving or rotating. Okay. That is the moment of a couple. That's commonly called as moment of a couple. Its formula is either force means if you take this force or this force, both are of same magnitude. So you take either force into perpendicular distance between two forces. If distance between these two forces. Okay. इसके बीच कंडीशंस, then you have always this concept within your mind to when you are applying. Okay, torque means moment is a force into perpendicular distance. Again, moment of a couple is a force into perpendicular distance between the forces. This is the distance between the point of axis of rotation and force. And this is the distance between the two forces, not the point of rotation. Okay, you have to be clear about this two formula. Otherwise, it will be in trouble while solving the numerical. Okay. Next point we have studied that in third, that the principle of moment. Principle of moment is similar to conservation of momentum. It means that the sum of anti-clockwise moments is equal to sum of clockwise moments. If we have formula for this, F1 L1 is equal to F2 L2. It means that if we are taking force in anti-clockwise and length in anti-clockwise, that is becomes moment in anti-clockwise. And we will also take this formula, real force, by replacing the weight. Weight and force both are similar. That's why we can replace this force by a weight. Okay. So we have discussed these three main formulas in the 4 part of our videos. From 1 to 4, we have discussed these all topics. Now we have to do some problems. Okay. So in this video, I am starting from the last numerical of your solved exercise. Okay. In solved exercise, question number 11, it is saying that in the given figure, okay, that I have drawn here. Okay. In the given figure, a rule AB pivoted at its end A at the 0 mark and supported at the other end B by a spring balance, means that it is AB is a ruler which is pivoted at point A, that is at 0, okay, and another point B is hinged, fixed with a spring, okay. Now, in this question, it is saying that by a weight of 40 kg is suspended at the point 40 centimeter mark. Means 40 centimeter marks पे एक 40 kg का weight क्या किया गया है, hang out किया गया, okay. And he is asking find the reading of the spring balance when the ruler is of negligible mass and when the ruler is of 20 kg mass, okay. Means it is asking you simply find the force applied at spring when we hand 40 kg of weight at 40 degrees, 40 centimeter, okay. So we have already studied that part A. We are solving. We have already studied that the principle of moment is sum of anti-clockwise moment is equal to sum of clockwise moment. Okay. We can also write it as sum of clockwise moment is equal to sum of anti-clockwise. It is not to worry. Okay. So if 40 kg of weight I am hanging here at 40 centimeter, means this weight will what bring this ruler down. If we disconnect this spring and if it's connected, if the spring is connected, the ruler will definitely not come down because it has been hinged. Some force has been added. That what amount of force should be required that this ruler will not come down. Means point B will not come down. Means हमने आपको ये बताना चाहता है कि B पॉइंट जो रूलर का B इंड है, अगर यहाँ पर डिस्कनेक्ट होता तो ये नीचे आ जाता, क्योंकि ये वेट इसको ब्रिंग डाउन करता, नीचे लोअर करता, क्योंकि इस पे ये फोर्स लगाता और इसको नीचे ले जाता। लेकिन ये कनेक्टेड है तो कुछ फोर्स यहाँ पर लग रहा है, डेफिनेटली वही फोर्स आपसे पूछा गया। You have been asked this force, what amount of force applied at the spring balance so that the ruler will not come down, okay. And in the first case, it has mentioned you when the ruler of negligible mass, means ruler has no mass, okay. If ruler has no mass, only one weight that will allow to bring down the ruler, okay. So clockwise movement, we have studied that how to find moment. Moment is equal to force into perpendicular distance, okay. Force of 40 kg is, let's say that is F1. F1 is applied downward, and distance between this is L1, okay. That is the product become what moment? The product of F1 and L1 become moment. So it is clockwise movement. Why I am saying that clockwise movement? If we put our right hand plumb on the force and rotate it towards the perpendicular distance, then it will be inside. So we have taken a clockwise movement F1, F1, and anti-clockwise movement. Anti-clockwise movement, that is produced by F2, F2. I am saying that this force is F2, which is applied by the spring balance, okay. We don't know what is this force, but let us assume that F2 is force applied by spring balance, okay. And the perpendicular distance from point A is 100 centimeter. So we have studied that clockwise moment about A will be equal to anti-clockwise moment about A, okay. So F1 L1 is equal to F2 L2. So now we will put the value of F1. F1 has a value of 40 kg into L1 has a value of 40 centimeter. That is equal to F2. We mark that, or simply we say that F. Okay, F and what? 100. The distance from point A of F is what? 100. Okay, so F will become 40 into 40 divided by 100, that is 60 kg. Okay, that will be in anti-clockwise direction. Okay, so now we will come to the second part of this numerical. Second part of this numerical is that if the ruler has some mass, अगर रूलर के पास कुछ मास है तब फिर क्या होगा आपको कैलकुलेट करना। ओके, सेकंड पार्ट we are going to deal, that is if ruler has some mass, अगर part B I am mentioning it, when the rule is of mass 20 kg. Okay, अगर रूल तो हम लोग अगर ये मास है 20 kg, then we take as its weight, weight that is equal to 20 kg. Okay, 20 kg. Okay, it means that it has mentioned that if ruler has of mass 20 kg, mass is always applied at the center of the gravity of a body. Means that if any object, if this notebook is appearing balanced, it means that I am applying force on the center of this object. Okay, so the ruler is of length 100 centimeter. Where will be its center? Of course, at 50 centimeter, it will be a center half, because 0 to 50 and 50 to 100. So at 50 centimeter, there will be a force of what? 20 kg. There will be a force of 20 kg. 20 kg. Okay. This force will also bring this ruler down. So again we will apply what? The clockwise movement is equal to anti-clockwise movement. Clockwise movement will be equal to anti-clockwise about the point A. So now some of clockwise movement. First of all, it will be A1 plus. Now I am changing, renaming it. Okay, I have taken F2 this 20 kg. F2 हमने क्या मान लिया है? F2 मान लिया है. F2 L2, and the force which is applied by the spring balance to hold this ruler horizontal, I have taken this F, that is F3, L3. Okay, I have taken this F3 is equal to F, that having the force applied by spring balance to hold this ruler. Okay, so F1 we have already known that 40 kg, 40 kg. into L1 that is 40 centimeter plus F2. F2 is of 20 kg. Okay, into L2 of 50 centimeter is equal to F3 that is F into L3 that is of 100. Again, L3 becomes 100 because A is pivoting. From A I am taking the distance. Okay, so L3 becomes 100 centimeter. Okay, we have to find F. Okay, so we will multiply this. This will become 1600. 1600 4 just 16 or I'm still it's plus this will become 5 to the 10 1000. Okay, is equal to F into 100. Okay, this will we will add it up, that is equal to 2600 is equal to F into times. So F the force will become 2600 upon 100, that is 26 kg. Okay. So I hope that you are able to understand this problem. Okay, if any problem arises with you, kindly mention it on your comment that I am not able to understand that I will solve you from lower problem. Okay, bye.